NASA and SpaceX just got hit with a wake-up call. Because while the world was watching Starship prototypes explode on the launch pad and Artemis timelines slip further into the future, China was quietly building a set of space technologies that honestly shouldn't exist this soon. And the most shocking part, these aren't concepts drawn on a whiteboard somewhere in Beijing. They've been tested, they're funded, and they're arriving this decade. We're talking about a space telescope with 300 times Hubble's field of view, an electromagnetic maglev launch pad that could slash rocket fuel requirements by 40%, moon bricks made from real lunar soil already tested in the vacuum of space, a laser internet network already transmitting data at speeds that make Starlink look like dial-up, and a six-legged insect-inspired mining robot designed to drill on asteroids without floating away. One by one, each of these projects is impressive on its own, but when you zoom out and see them all, together a pattern emerges that has U.S. space officials genuinely alarmed. China isn't building one breakthrough. It's building an entire ecosystem of space power, all at the same time, all pointing toward the same destination. And NASA and SpaceX are only now beginning to realize just how far behind they might already be. Let's start with the sky, because China just built something that could rewrite the rules of space astronomy. NASA expected to dominate orbital science for the next decade. The James Webb Space Telescope is the crown jewel of modern astronomy, a machine that peers into the earliest moments of the universe with breathtaking precision. And on the horizon, NASA's Nancy Grace Roman Telescope promises to expand that vision even further. For years, the assumption in Washington was simple: America leads in space science. Full stop. Then Xuntian appeared. The Xuntian Space Telescope, also known as the Chinese Space Station Telescope, is China's answer to Hubble and Romans combined, but it isn't built like either of them. Unlike Hubble or JWST, which drift alone in orbit with no way to be serviced once launched, Xuntian will orbit alongside China's Tiangong Space Station and physically dock with it for upgrades, repairs, and instrument swaps. That means astronauts can maintain Xuntian in orbit, something NASA lost the ability to do entirely when the Space Shuttle retired in 2011. Inside the telescope sits a 2.5 billion pixel camera, one of the most advanced space imaging systems ever placed in orbit. Its resolution is roughly on par with Hubble's, close enough to stun any astronomer. But here's where the real shock lands. Xuntian's field of view is 300 times larger than Hubble's, 300 times. One Chinese scientist described it like this: Hubble may see a single sheep. Xuntian sees 1,000 all at the same resolution. Think about what that means in practice. Massive sky surveys, deep maps of dark matter, detailed studies of galaxy formation across billions of light years. Exoplanet hunts at speeds no Western telescope can match, all from a single Chinese instrument that can be upgraded by hand whenever something better comes along. Yes, Xuntian has faced delays. Its launch is now expected in late 2026, putting it roughly in line with NASA's Roman telescope scheduled for 2027. Roman will still be extraordinary. It offers about 100 times Hubble's field of view, a genuine leap forward. But Xuntian goes 3 times wider still. That gives China a massive survey advantage at exactly the moment when wide-field sky mapping has become the most competitive frontier in modern astronomy. Behind the scenes, U.S. scientists have quietly acknowledged something uncomfortable. If Xuntian performs as expected, China may become the dominant force in wide-field space astronomy within the next decade. NASA hasn't said it publicly, but the concern is real, and it's only the beginning, because the next Chinese breakthrough doesn't threaten NASA's telescopes. It threatens SpaceX's entire launch business. SpaceX changed history by making rockets land. China wants to go further, much further, and they're building something the world has genuinely never seen before. It's called an electromagnetic maglev launch pad, and it is exactly what it sounds like. Instead of blasting a rocket vertically off a pad, this system places the vehicle on a horizontal superconducting magnetic rail and accelerates it to supersonic speeds before the engines ever ignite. It sounds like something pulled from a science fiction novel, but construction is already underway in China with a working prototype targeted for 2028. In early trial runs, the system has already pushed test vehicles to around 1,000 kilometers per hour. That's impressive on its own, but the real target is a staggering 5,000 kilometers per hour, a launch velocity that would fundamentally change the economics of getting to space. Here's why that matters. The biggest cost in rocketry isn't the hardware, it's the propellant. Getting a rocket from zero to orbital velocity requires an enormous amount of fuel, most of which is burned in those first few minutes of flight. If you can pre-accelerate the vehicle to supersonic speeds on the ground before the engines light, you can cut fuel requirements by 20 to 40%. You reduce acoustic stress on the rocket. You enable faster turnaround times. And instead of rebuilding a chemical first stage every mission, you have a permanent electric-powered ground launcher that fires rocket after rocket, day after day. SpaceX wants to reuse the rocket. China wants to reuse the ground itself. Interestingly, NASA actually explored this concept back in the 1990s under a program called MagLifter. But the materials science wasn't ready, funding dried up. The idea was shelved. China has now picked up exactly where NASA left off, and they are years ahead of anyone who might try to catch them. For SpaceX, which has built its entire competitive moat around reusable rockets, this could be the most disruptive launch technology to emerge in decades. But what China wants to launch with this system, that may be even more significant than the launcher itself. The moon is becoming strategic again, and China isn't just planning to visit it, they're planning to stay. By 2035, China wants the core of a permanent lunar base operational at the South Pole, and the roadmap to get there is already locked in. In 2028, China will launch Chang'e 8, a mission designed to test solar-powered 3D printing using real lunar regolith directly on the surface. The goal is to prove that you can build structures on the moon using nothing but the soil beneath your feet. No supply chains from Earth, no prefabricated habitats launched at enormous cost. Just a machine, some sunlight, and the dust that covers the entire lunar surface. But here's the detail that stunned NASA engineers when they heard it. China didn't wait for Chang'e 8 to start testing. Scientists have already built prototype moon bricks using high-powered lasers and simulated lunar dust, and then they did something bold. They mounted those bricks on the exterior of the Tiangong space station and left them there for a full year, exposed to raw space weathering, radiation, thermal extremes, and the micrometeorite environment of low Earth orbit. They passed. These aren't laboratory curiosities, they're flight-proven construction materials for a future moon base, and they feed directly into China's larger vision for the lunar South Pole, a concept sometimes called Guanghan Palace, a modular underground habitat built from 3D printed regolith structures forming radiation-shielded rooms, tunnels, laboratories, and eventually fuel production facilities spread across the most valuable piece of real estate in the inner solar system. NASA's Artemis program absolutely aims for a long-term lunar presence, but NASA has not yet flown a regolith printing experiment. China is preparing to test one on the actual lunar surface within 4 years. That gap between planning and doing, between concept and hardware already tested in orbit, is exactly the kind of gap that tends to define who wins a space race. And while China is preparing to build on the moon, it's also quietly preparing to dominate the sky above Earth. SpaceX's Starlink constellation has transformed global communications. More than 6,000 satellites now beam internet to remote corners of the planet that have never had reliable connectivity. It's one of the most impressive engineering achievements of the modern era, and China noticed. Between 2024 and 2025, China achieved something in laser communications that nobody in the West was fully prepared for. Beijing-based Laser Starcom demonstrated a 400 gigabit per second laser link between two satellites. To put that in perspective, that's 14.4 terabytes of data transmitted across 640 kilometers of space in just minutes. At the same time, state-owned Changguang satellite set another record entirely, a 100 gigabit per second satellite-to-ground laser transmission, enough bandwidth to send 10 full-length movies to Earth in a single second. Starlink, for all its scale, still relies primarily on radio waves for its Earth links, with only limited optical crosslinks tested since 2022. NASA's most advanced laser communication demonstration, the LCRD system, achieves 622 megabits per second. China's numbers are not in the same conversation, they're not even in the same category. This laser highway, as Chinese researchers are calling it, is the closest thing space has ever seen to a real-time, high-bandwidth backbone in orbit. It could power future 6G networks from space. It could move reconnaissance imagery in near real time. It could enable encrypted military communications at the speed of light. And it could eliminate the need for the massive, expensive ground antenna arrays that current satellite networks depend on. China isn't stopping at a record demonstration either. The entire Jilin-1 satellite constellation, 117 satellites in total, is planned to be fully laser-equipped by 2027. A Chinese researcher described it as opening hundreds of highway lanes in orbit all at once instead of one. For Starlink, that comparison stings. because SpaceX built the highway. China is now preparing to build one that's fundamentally faster. But perhaps the most quietly alarming thing China has revealed isn't a telescope or a laser. It's a robot, and it's small enough to hold in your hands. Meet China's six-legged lunar and asteroid mining prototype. Developed by researchers at the China University of Mining and Technology, this machine doesn't look like a rover. It moves more like an insect, and it was designed to solve one of the oldest unsolved problems in space resource extraction. In microgravity, drilling is almost impossible. The moment a conventional drill bit touches rock, the reaction force pushes the entire machine away from the surface. You can't drill if you can't stay put. NASA has struggled with this challenge for decades. It's the reason resource extraction on asteroids or the lunar surface remains largely theoretical in American planning documents. China's insect robot solves the problem biologically. It has 3 wheel legs for mobility and 3 claw legs for anchoring. The claws are inspired by the gripping mechanisms of insects, biomimetic designs that latch onto uneven terrain and hold the robot in place even under the reaction forces of active drilling. In laboratory tests on simulated regolith under low-gravity conditions, the robot walked, latched, drilled, and held. The design is already patented. It has already appeared in state media demonstrations. It is already real, and it fits into China's lunar roadmap with unsettling precision. A crewed moon landing by approximately 2030. A permanent research station by 2035, on-site resource extraction to make that station self-sustaining. Water ice converted to drinking water and rocket fuel, metals mined from the surface for construction, oxygen extracted to keep the lights on. The insect robot isn't a science project. It's a piece of the supply chain for a permanent human settlement. NASA's Artemis program talks about in-situ resource utilization, but NASA currently has no robotic analog to this mining system. Its Viper rover was designed for mobility at the poles, not for anchor drilling on asteroids or regolith extraction. Meanwhile, China is prototyping the machines that will actually do the work when the base is built. A 6-legged insect robot may not make headlines the way a Starship launch does, but strategically it could be the most important machine China has unveiled in years. Because whoever controls the moon's resources first, water, metals, oxygen, hydrogen fuel, controls the infrastructure of everything that comes next. Now zoom out. Look at all of it together. The telescope, the maglev launcher, the moon bricks, the laser network, the mining robot. Individually, each project is impressive. Collectively, they reveal something far more significant than any single breakthrough. China is not playing catch-up anymore. China is building an integrated space civilization from the ground up all at once on a timeline that is tightening rather than slipping. Projects once penciled in for the 2035s are being pulled forward to 2027, 2028, 2030. Milestones once dismissed as aspirational are becoming hardware you can touch, orbit, and test. There are 3 strategic goals that tie all of this together. First, orbital astronomy leadership. Zhutian gives China survey power that NASA didn't expect to face competition for until the next generation. Second, control of the space internet. Laser-equipped constellations could reshape the global broadband market and give Beijing a communications infrastructure that rivals or surpasses anything Washington currently operates. Third, permanent lunar presence. The 3D printing tests, the moon bricks, the mining robot, the crewed landing timeline, and the Chang'e roadmap all point toward the same destination. A base on the moon that doesn't just exist but operates, produces, and sustains itself. NASA and SpaceX are not standing still. Artemis is real. Starship is real. Roman is real. The United States still leads in many critical areas of space exploration, and the depth of American aerospace talent is unmatched anywhere on Earth. But the assumption that America would simply remain dominant without facing serious, capable competition, that assumption is gone. Because right now, China isn't just building rockets. It's building the next chapter of human civilization beyond Earth. And the world is only beginning to understand what that means. The real space race isn't about flags and footprints anymore. It's about who builds the infrastructure, who owns the resources, who sets the rules for everyone else. And who, when history finally judges this era, was building not for a headline, but for forever.